In this video, I'm going to go over how to draw the covalent Lewis dot structure for H2S, which is hydrogen sulfide. You're going to begin by drawing out each element that is in the compound along with its valence electrons. So we have 2 hydrogens and 1 sulfur. Now, unlike ionic Lewis dot structures where it didn't matter where we were drawing those, when we're setting up our covalent Lewis dot structures, we want to think about where we're putting these elements. So if you ever have a single element, like we have sulfur right here, you want to put that in the middle. And then the other elements you want to put around it, especially hydrogens. Hydrogens are always going to be around the central atom, okay? Because hydrogens will only form 1 covalent bond. So since there are 2 hydrogens, I'm going to put 1 on either side so that it's symmetrical. So again, you want to put the element that is by itself or you only have 1 of in the center, and then you want to put other elements around it, especially hydrogens. So I'm putting a hydrogen on 1 on either side to make it symmetrical. Next, we're going to draw in our valence electrons. So sulfur is in group 16 on the periodic table. So we're going to draw 6 valence electrons around it. 1, 2, 3, 4, 5, and 6. Okay, and again, we can move our valence electrons around. That is okay. For example, I'm going to take this guy right here. Instead of being over there, I'm going to put him right here. Okay, this is still the same thing as I had before, but I want to put the lone pairs on the outside here, and then electrons that are by themselves, I want them facing other elements so that I can create bonds. I'm actually going to draw the hydrogen in a different color just so that you can see the difference with the elements. Hydrogen is in group 1. It only has 1 valence electron. So I'm actually going to draw it here so that it's facing the central atom. And I'm going to draw the other one here so it's facing the central atom. We want those electrons that are by themselves that are not in a lone pair. Remember, this is what we call a lone pair. A lone pair, they will not participate in bonding. However, electrons that are by themselves, they will participate in bonding. So now I'm going to rearrange my model here a little bit. So we're going to take this hydrogen, I'm going to move it over. So now those electrons are being shared. Okay, I'm just going to erase that. So these electrons here, they're being shared. This is forming a bond. So since we're sharing 1 electron from each element, that would be a single bond. And then we're going to do the same thing with this guy. Okay, so now these electrons are being shared, and that would also be a single bond. I also know that this is correct because the sulfur is surrounded by 8 valence electrons, which is what we want. We want that octet. However, the hydrogen is only surrounded by 2 valence electrons because that's the max that hydrogen can have. It's one of the exceptions to the octet rule. So for my final answer, I would have the sulfur in the center here, and I would have its lone pairs here. And then instead of those 2 electrons, I'm going to draw a bond. Okay, that bond is representing 2 electrons that are being shared. Okay, if you have 4 electrons between 2 elements that they're sharing, that would be a double bond. If you have 6 electrons that are being shared, that would be a triple bond. Okay. And then that would be this right here, this entire thing. That would be my final answer for my Lewis dot structure.